Today we're going to be talking about one of the segments on minerals. This presentation coincides with the opengeology.org textbook that myself and other authors have created for Salt Lake Community College and other campuses throughout the world. Today we're going to talk about how minerals form, and what it boils down to is it's essentially crystals coming out of a liquid of some type or another. You're crystallizing minerals from a liquid. And this is, on the atomic scale, atoms bonding together and forming solids, which are your minerals. Solids in an orderly crystalline structure. Today we're going to talk about 3 ways this can happen, but keep in mind that there are other ways, including the rearrangement of these bonds and atoms through metamorphic processes. We're going to talk about precipitation from an aqueous solution. We're going to talk about crystallization from magma, and talk about biodeposition, which is a little bit debatable in terms of how you define a mineral, but we'll talk about it anyways. In every case, what you have is a liquid. In many cases it's water, but it can also be magma. And you have tiny atoms rearranging ions, rearranging themselves and grouping together and bonding together to form these crystals, these mineral crystals. In the case of precipitation of mineral matter from an aqueous is just fancy word of saying a water type solution, we have ions, things like sodium and chloride, atoms of sodium and chloride, charged particles floating around in the water. And if you change the environment, the environmental conditions of that water, such as if you start to evaporate it or change its temperature drastically, or increase the number of charged atoms, ions floating around in that water, then you can start to form a mineral. You start to crystallize these solids. So here is a picture of one of the examples of where this happens. Right near here, the Great Salt Lake in Utah, United States, we have halite and gypsum actively forming where water is evaporating in this interior drainage basin. And as that water evaporates away, it leaves behind these ions of sodium and chloride. And they become more and more concentrated over time until finally they crystallize and form the mineral halite. And you can have a lot of other conditions where you get the same kind of crystallization. If any of you have ever conducted one of those home science experiments where you make your own candy by crystallizing the sugar out of solution or the salt out of solution onto a wand or something similar, that's the same idea. That is what we call precipitation out of aqueous solution. Here is a link to how it's made on salt from the Great Salt Lake, for those of you who are interested in learning a little bit more about the industrial applications of evaporites. You can also get crystallization of molten rock. Same idea as the solution, in this case molten rock, starts to cool off. The different ions floating around in the magma start to slow down and bond with each other and connect and form new minerals like feldspar and quartz or olivine, depending on the composition of the magma. And the sequence of cooling follows that of the Bones reaction series, which we talked about in the igneous rocks lecture. And you can think of this as just like water freezing, except the magma freezes at a much different temperature than water. And then the third example we'll talk about is deposition from a biological process. And this is actually a little bit debatable depending on how you define a mineral, because marine organisms are pulling the calcium carbonate out of the water and forming their homes out of it. And a lot of times they're forming the mineral aragonite. In some cases they're forming calcite. And later on, these minerals are altered by geologic process, which then definitely makes them minerals in terms of the official definition. And we'll talk about that when we talk about how minerals are defined. Here is a YouTube link to a great time lapse showing this deposition of calcium carbonate by a coral in an aquarium over time. It's basically these little critters grabbing these ions, these charged atoms out of the water, and these molecules, and combining them to form their shells. And that is it for how minerals are formed. If you like this video, please watch some of the other videos that I have, and I hope you enjoyed it and learned something.